Hello, my name is Peter Thielmann, and today we're going to be going over my Data Practicum 2 project. Now this is a continuation of the Data Practicum 1 project. If you haven't seen that, I'll leave a link to the video in the description. This project is basically the implementation of the model that was built in the first project. And some of the objectives for today is to provide an overview of the implementation processes and methodologies, as well as review the fraud model that was built in the first project. We're also going to discuss the business and team impact and review some applicable next steps. If you look at the data science life cycle, you can see that it kind of starts with that business understanding and then kind of moves to the data acquisition, understanding, data processing, and then we move to modeling. Now all of this was kind of packed into that first project, and this project's really going to focus on deployment. From that graph you can kind of see scoring, monitoring, model storing, web services. That's kind of the general idea of this project. You can see on the right there I have deployment and implementation. That's kind of what the project all entails. It's not really one thing, but kind of a combination of those. Before we dive into the recap, some common insurance terminology: policy, premium, deductible we might be familiar with. A claim is a request to the insurer to receive compensation for a covered loss. The claims adjuster is an employee who's responsible for handling the claim or investigating the claim. And we define insurance fraud here as someone who attempts to obtain a benefit or advantage to which they're not entitled. So to quickly recap, our first project built a claims fraud model that was used to detect a fraudulent claim. The way we built it was a gradient boosting classifier, and we did some data pre-processing, bootstrapping, things like that. And at the end of the project, we looked at the model and how it performed. To segue into this project, our model left off with providing a prediction as well as an explanation of why a claim may or may not be fraudulent. So this product really focuses on how we're going to implement that model. I want to do a quick disclaimer. Some parts of this project might get a little bit technical, so feel free to ask questions. You can leave one in the comment, but I'll do my best to try to explain some of the more difficult topics. So an API stands for Application Programming Interface, and really what this does is just allows an application to talk to another application. Kind of provides that endpoint for which they can talk to each other, as well as sort of the format on how they'll talk to each other. The benefit of this is that we're able to automate this model scoring process. Once you have a model, you can output some scores, which is great, but eventually you're going to want to do this in real time, and you don't want to do this by hand. So the API kind of gives us a way to automate this using a standardized communication method. The format in which we'll be communicating with our application is known as JSON. JSON stands for JavaScript Object Notation. Really all it is you can see the example. We have user, password, policy number. It's just the way that the application accepts data and sort of sticks to a format. You can see it's a keyword in strings with a colon and then the value and then a comma for the next value. The benefit of this is that it's a commonly used data exchange format, which is sort of an industry standard. And it's also human readable, so it's kind of easy to troubleshoot if we see something that we're not expecting. The application was built using Flask, which is a Python package that provides a framework for our application, sort of the architecture. It also allows us to define endpoints, or a place where our client application or our calling application can interact with. If you ever notice, like Amazon.com, you'll see a backslash to a different web page, and that's kind of what Flask does for us. Now let's take a look at some of the functionality of the application. Some of the major features, as we already explained, were the background processes that run every 24 hours. a scoring function so we can provide a prediction from our model, a dashboard, and then an email that's generated. Some of the minor features are database tables and calls, um, the ability to have minimal data input, as well as pre-process our data in real time. The background process will compare feature distributions to detect through time drift. As a model gets older, the data that we're inputting might change, and this is a way to detect how much it's changed, as well as kind of notifies us if we need to recalibrate our model. The way we do this is with a Mann-Whitney statistical test, which is non-parametric to detect these differences. Our background process will also generate an email that will provide us with an automated alert when these differences occur. Our scoring function accepts a JSON input, makes a data call that gathers all the data that's needed, pre-processes, creates our interactive feature, calls the model for prediction, runs our prediction explain, stores the scoring result in the database, and returns the JSON. A product called Postman was used, and really all this is a way to test our application to make sure it's working how we think it should be working. So heading over to our browser, we can see that if we type in the URL for our dashboard, it brings us right to the feature distribution analysis. This was built using Dash, and you can see the Plotly graphs that are part of Dash have a few different things. On top we have what's known as a box plot, and this really lets us see real quickly what the differences are in the mean, quartiles, medians, things like that. On the bottom we have our actual distributions shown in histograms. All in all, it's a pretty simple dashboard. I wanted to build something that was interactive, but also provide the framework to build on in the future. So let's go ahead and jump into a demo for the entire application.
Okay, now we're going to demo the application real quick. What we're seeing here is our Anaconda command prompt, and from here we're going to enter a few commands to get our application running. The first command will activate our virtual environment for which the application to run. Second command will navigate us over to the application's directory, and finally we will run our application. Now you'll see a few things happen when we load the application. The first thing we do is instantiate the Dash server and load the dashboard. Then we launch our application, which will load our serialized model and make a few database calls for things that our model needs to run. I think what I'll do first is go over to Postman and send a GET request to our API. And I'll do that right now. Okay, we can see that our API returned successfully. I have a few prints here so we can kind of see what's going on. First, we see that the call was made from Postman and the JSON that was input. Basically, I just showed the user and the policy to run the model on. The first thing the function will do then is select the policy data from the database and kind of run through pre-processing of the data, apply capping logic, categorical encoding, things like that. And then we call our model's predict function. We can see in this case that the model predicted fraud, at which point we will call the ELI5 for a prediction explanation and then store those results in the database. Finally, at the bottom, we can see the return JSON string, which is our policy number, the prediction, as well as some of the prediction data. Okay, now we can see that our background schedule job has run. The first thing that it does is pulls in the training data and the new data. If you remember, the new data is a rolling average, maybe the last 3 to 6 months. We're going to go ahead and perform our Mann-Whitney U test, and I've output each independent feature along with the test statistic value and the test conclusion. So if we look at the first one, we can see the months as customer distributions were tested between the training data and the new data, our test statistic value, and that the test concluded that they're not statistically different. So there were one or two that were actually different. Let me see if I can find one here quick. Right here, capital loss. So we can see our test statistic value of 0.01 and our cutoff is 0.05. So the test will then conclude that they are in fact different. At the end, we noticed that at least one was different, so an email is generated and sent successfully. And I've output kind of a quick display of the message, and we kind of saw those in the slides. After the email's generated, the application will store the visualizations for each difference that it finds, and the dashboard will pick those up every day so we can go ahead and investigate.
Sorry about the audio quality on that demo. The screen capture software I was using kind of changed things up. Moving on, we're going to look at how this impacts the team. First up, modularity and integration. This provides a framework for future products. We get to reuse components that other applications or projects might use. Also allows us to easily integrate with other IT applications. Model recalibration efficiency. Models get stale through time. This gives us a quick way to move from development to production, as well as the dashboard provides us with a kind of a quick way to see what's going on. I'd like to talk about business impact a bit more, but we're kind of running short on time. One of the things that this really helps us with is efficiency. Under promise, over deliver. This reduces work hours for product development, as well as deliver quality products. We can spend more as well as on quality work like the modeling, data exploration, rather than the logistics of how we might deploy this. It also gives us a cool presentation tool. We can put a demo product in the hands of the user sooner rather than a final product months later. This also provides faster feedback, important feedback that we might not see during testing. And we can also use this to pitch new ideas in a presentation. Where I'd like to see this project go in the future is a focus on SQL replication or some sort of data pipelining. When you get a school project or you do a tutorial online, you're provided with a nice, clean CSV, and that's how it is in the real world, right? Usually there are existing systems that you have to go after, transactional databases, and it's not very clean. Having a process that handles this, maintains a single source of integrity, allows us to provide real-time analytics, and we can take our queries and go straight from development to production. We kind of briefly went over what I'd like to do with the dashboard in the feature, but this involves adding additional drop-downs, additional screens, filter criteria, possibly add continuous learning. Really, the framework's in place and the sky's the limit on this, but there's definitely a nice framework to build off of. So, what did we all see again? For this project, we focused on deployment, which involved scoring functions, dashboards, background processes, email generations, and a bunch more. I think when we started the first Data Practicum course, our professor said, this is your chance to show us what you've learned. And I think by taking a model from the beginning of that business understanding, data understanding, all the way to implementing an application is kind of the whole package. So if you guys have any questions, again, leave them in the comments, but I just want to thank you and have a great day.